So good morning and good afternoon. Welcome everybody to the webinar on improving production quality and digitized process control in EMS industry. So my name is Saurabh Boris. I'm CTO at Nexustec GmbH, and we have brought this webinar in collaboration with our distribution partners from India, Sachin Anand Group. And I would like to welcome every one of you to this webinar who are here to understand how we can add value to your manufacturing with our product TRiMiTi. So before we deep dive into the topics for today, I would like to introduce Nexustec in general. What do we do? What is our uniqueness? And what kind of services we offer? So as all of you may be aware that the Industry 4.0 is the big topic everywhere around the world, but the manual work processes are still not a part of Industry 4.0. What this means is basically all kinds of processes where human worker comes in, they are either unmonitored, they are not at the same standard as that of a digitized processes, which are automated, often using robots, several sensors, which means integrating manual processes as they are into the Industry 4.0 framework is quite a hassle. Now, what we offer or what we ensure from our side is zero defects in manufacturing. And we will go a little bit in detail in this webinar about how we enable you to have zero defects in your manufacturing and how we can safeguard against shortage of skilled workers. So effectively in EMS, when it comes to quality control, we have to always assume the worst case scenario that the employees who know most about the quality are often unavailable. And in that kind of scenario, if you rely only on people and know-how that your people have, then your processes might suffer. And what we do is we offer you a system-based solution, which can effectively congeal and cohesively bring all the knowledge together in a system, which means it's infallible compared to absence of humans or things like that. Now, what we do on top is we enable advanced process control, which is similar to automated process. And we also collect the data throughout the manufacturing process, which means you can do a data-driven, resource-optimized manufacturing for your manufacturing processes. So we know quite a few problems that are manufacturers facing around the world. So there are high costs of rework, for example. The manual work quality is quite difficult to monitor. You have applications which do the inspection, which are limited to the end of line control, which means if something fails the inspection, you have to either rework or scrap. And those are the only two options. Both of them cost a lot. Then you have a high cost for hardware and overhaul services, which are provided by large companies. And most of the softwares which are developed, they're isolated solutions. Now, what we did is we took a holistic look at this problem and we tried to understand what exactly does the manufacturer do, where is the value addition, and what exactly are the pain points. And the reason why we could do all of this holistically so that we can address all these problems at once is because we started working together from the OEM level all the way down to tier 2, tier 3 level. And effectively, when we work with multiple companies up and down the chain, we understand what are the problems which are faced by, for example, a tier 2 supplier versus what is a problem faced by OEM. And if we can find a sort of a least common multiplier of these problems, then we can address those problems in a way that they can be addressed for all of them at once. So as you can see, what our solution does, it provides you zero defects, which means you don't have to work with the rework or complaint cost, but it also provides you a complete traceability of all of your workspace, all of your work steps, your tools, all of the quality control. What TRiMiTi does, it provides you an inline quality control or real-time inline quality control. And the benefit of that is basically you don't have to worry about rework and you don't have to worry about doing any kind of activities at a later point. So one of the major benefits we bring to this table is all of the hardware is off the shelf, which means as a customer, you have choice of multiple different hardware possibilities. So you can choose cameras from 3, 4 different vendors. You can choose a computer from your own vendor. We have a software-based solution, which can also integrate other software solutions. So all of these things considered, TRiMiTi is going to address not just the semi-automated and automated workstations, but also the manual workstations. And we will see how. So to give you a brief understanding, what we have done is we have split our product into 5 packages. So we have packages which do the inline quality control or inline quality check, and we have packages which do the end of line quality check. And if you look at the 5 products on the screen, we have products which can be used in assembly or normal assembly areas. It can be used together with digital control tools such as screw fastening assistant. Then we have optical inspection that can work inline or end of line, depending on where your requirements are. But there is another critical quality failure which happens in the end of line is the packaging, which means you have done the manufacturing well, but somehow one of your worker misplaces the package, which means he either mixes them up, or a part which is marked for rework or which is marked as NOK ends up going out to a customer. And now both of these things are not acceptable. And effectively what we do is we provide monitoring also of the end of line area so that we can ensure this doesn't happen. And now to do this, how do we do that? So we have a major statement from our side is that we focus on human-centric automation. So humans are quite smart, and we have the dexterity that most of the robots can only imagine or not even imagine of. So effectively, when we combine these two things with the automated process control, then we get the best of both worlds. Now, of course, being a European company, one of the questions we are always asked, what about the data storage or what about the GDPR compliance? So our system is completely GDPR compliant. And when we go to India, it's also DPDPR compliant, which what that means is basically data that is generated by TRiMiTi. It's stored on an industrial computer on your location. So we don't always back up the data to the cloud. So of course, there is an option to back up the data to your preferred cloud vendor or to a cloud vendor provided by Nexustec, but it's not done by default. So we need an explicit consent from the customer to do that. But also we have a software which ensures personal data protection, which means we do not record any videos. We do not store any of those video data. We only store the images of the products or parts which are being assembled. And that too also done on the request from the customer. Then the focus is primarily on the production flow, ensuring the process has the highest priority and not tracking people. So effectively, by addressing these 3 different topics together, we can ensure that we are not there in the business of monitoring and tracking people, but we are ensuring that you have 0 defects in your manufacturing. Now, once we go to the EMS and focus on the EMS manufacturing areas. So I know it's a bit of a misnomer, but yeah. So when we go in EMS industry, we have quite a few questions or quite a few problems that need to be addressed. So you need to have the correct parts or correct components. These components, they need to be checked so that there are no defects. And the wrong parts, they need to be sorted out. But at the same time, you have to also ensure that the quality is uniform across the batch of production, and it's also high according to your customer standards. You have to also ensure that the processes are followed correctly, which means if you have to assemble a board before it goes for wave soldering, then you have to ensure that all the components are placed in the correct sequence, correct position, correct polarity, all those things before the wave soldering is happening and not after, because otherwise it's a case of rework. And all variants and customer specifications, they need to be met. So in EMS, you often have a small batch sizes, but a lot of variety, which means we need to also be flexible in terms of adapting to the new variants. So what we do with our software, so TRiMiTi is the name of our software, and the name originates from a Sanskrit word, TRiMiTi, which means 3-dimensional. And we often say that it's because our software provides a complete mobility on all 3 dimensions, but also because it combines 3 different orthogonal requirements into one product. So what we do when we say process control in your production is basically we detect the correct assembly workflows, we check the manual work, but also TRiMiTi provides the worker guidance at the same time as making sure that the process steps are ensured. So we already have done quite a few integration into our system. So when I say we use off-the-shelf hardware, it's basically the TRiMiTi ecosystem, you can say right now, and it's growing continuously. So we have several production tools which are already integrated in TRiMiTi. We also have several camera distributors which are integrated in TRiMiTi. Same goes with the scanners and projectors. So you have a complex step workflow where you need to scan the barcode of a part before you put it into an inspection cube. We can basically provide you a one solution which can do all of those. But we also have system and control units integrated. For example, the Siemens, Bakehoff, all kinds of SAP systems are integrated in TRiMiTi, which means we can also do a production control, not just on manual stations, but also on semi-automated and automated stations. Now, as I said, it's our software, your setup remains the same. And when I talk about TRiMiTi earlier, we say we combine 3 orthogonal targets. So as you can see, we have data generation from every action. So every action that the worker is taking, we are taking a timestamp data, which means if your process step has, let's say, if your process has 20 steps, then we are taking 20 timestamps, which results in having a rich data set for all of your actions. Now, based on this data, you can analyze where exactly my workers are spending most amount of time and where exactly can I improve in my process. Now, the second thing that we do is we interface with every device out there. So as I shown on the previous slides, we have a rich ecosystem already and it's continuously growing. So whenever a manufacturer gets in touch with us, hey guys, we have a customer who wants to use our hardware, but your software, or vice versa. A customer says we have this particular hardware, but it's not integrated in your software. Then we do it right away for that customer. And once it's integrated, it stays in our ecosystem. Now, the process control, which is based on the ML-based description of production flows, and that's one of the biggest achievements that we have had, is to have a machine understandable language, which is also human understandable at the same time. So we can take the production processes as described in your normal production documents, and then we can translate that in such a way that the computer can also understand it. Now, the benefit of having all these 3 more or less orthogonal targets is that you can improve your process time, you can improve your cost saving, you have 0 defects, ensuring 0 recalls, and you can also have ergonomical improvements for your workers. So you will see in examples later on that oftentimes difficult to reach parts or difficult to reach components can be seen on screen in real time. So worker can do a better job or do it in a more relaxed and efficient environment, because worker knows that even if they make a mistake, our system is there to prompt the worker to make the changes right away, which means whatever leaves the station, it's not only the worker's responsibility to ensure that all the steps are followed as expected. Now, in your manufacturing environment, let's take at a glance how we can handle all of this. So as you can see here, we have 2 parallel flows. So you can do the online configuration in the beginning. That is for the TRiMiTi. So you can customize your product. You can customize what exactly you want inspected. Could be color, shape, different variants, different accessories. You can have stickers, things like that. And the material flow, as it flows in the production, the TRiMiTi will coordinate with different systems and ensure that the information flow is in parallel with the material flow. And the benefit of this kind of setup is that every serial number of your part as it's getting manufactured will have its digital passport generated in real time, which means when you reach end of the line production, and if you have a fault in the part, let's say, you can pinpoint exactly where was the problem. And in worst case scenario, if you're facing a recall of a certain batch, you don't have to recall the entire batch, but you can effectively analyze the data and see, oh, where exactly the processes are similar. So just as an example, if the seal was applied with insufficient amount of glue, then you don't need to recall the entire batch. You just need to check which parts in that particular batch did not have sufficient glue applied from your dispenser, and then you can only recall those particular parts, which effectively leads in further cost saving for you. Now, end of production line, all of this can be sent over to the ERP systems. They can also be sent over to your customer directly. So for a B2B, for example, in tier 2 and tier 1 customers, you can send your material and production information all together, which means you can look for further savings on your side. Now, in EMS, we look at 5 steps. So we have in the beginning, assembly assistant, which ensures for the manual manufacturing, all the parts are placed in the right location. But then we also do a quality check. We have a position where you need to do testing. So that could be electrical testing or optical testing, whatever is the requirements. Then we also have rework tracking. At the end, we will also talk about packaging content control a little bit. So let's look at the first step. So when we look at the assembly assistant, we have several features here that we can highlight. And unfortunately, I don't have a video for this particular part because all the products we have done so far, where you have to assemble components on a PCB, they were done under NDA for a specific customer, which means we are not at liberty to show those videos. But we have documented some defects on our custom boards, and we can just show you what we do. So we can check whether all the pallet stacking is correctly done. So all the parts are placed on the pallet in the right orientation. We can also do the check of orientation for the wave soldering or inspection. We can do the variant assembly check, so it can check the color, shape, positioning, all those things. But we can also do the polarity check, and we can also check individual components, whether they are of certain quality or not. So going one step further, just to give you an example how we can do the pallet loading check. As you can see here, it's a simple user interface. We have the pallet over there. Immediately it recognizes it needs to have 4 parts in there. And as the worker is mounting those parts, we will check the orientation, but we will also do a quick scan to ensure all the necessary components are placed on that particular PCB. And once all the items are mounted, you will basically say, oh, you need to now go to the inspection part, which is the one which follows next. So once we have done the assembly part, once we have ensured that all the components are there, we can even do a quality check before the wave soldering is taking place or before the SMD machine line is fed, so that we can ensure that, oh, all the parts that are going on are necessarily in the right position, in the right orientation, but also nothing is missing, nothing is defective. So as you can see here, on the 2 parts on the left side, our system already says that there is a defect with the pins that are up there. And on the PCB item 3, there was a defect with the diode. So the diode was scratched. So as you can see here, the diode was scratched. It's not the same as the other ones. But for the first one, you can also see slightly the pins are bent. So this is the quick optical inspection, which our system provides. And this can be, so right now it is done manually, but this can be put in line with your SMD or wave soldering or any of your machines which are doing automated manufacturing as well, which means we can do this process either in a manual workstation or in a completely automated environment. So the next part is interesting because right now, let's say you have already done quality check, you have gone through the soldering parts, and now you have finished and assembled the whole board. And now you need to do the testing. So you can do electrical constantly testing, you can do the functionality testing or different things. And in this testing, right now, there is some kind of PLC-based control or PLC-based system, which effectively you connect to the board, you run the test program, and that's that. But effectively, to reprogram this system, you need to have either a good understanding of a deeper programming language like C, or you need to have somebody at hand who can reprogram this quickly so you can do these tests. Or the alternatives in a lot of small batch manufacturing is that this testing is then done manually by a person with a scope and with 2 leads on a multimeter, for example, and then they will do the entire production batch like that. Now, the biggest problem is when we talk about a software-based control, we can also extend that control for the testing level. And we have already done some projects in this particular domain, and we are also working on functionality testing. For example, we have the testing for the assembled LED panels for a customer. So we check that all the LEDs in that panel are illuminating to the right brightness. And effectively, we can combine the electrical testing and optical testing together in one environment. Now, the benefit of this kind of software-based control is that the customized test programs, they can be written in TRiMiTi programming language, or you can also reprogram them in your user interface. So that can be done in minutes. And you can have a fully customizable test routines based on how many variants or varieties of boards you have. Now, what we did was integration was put on emphasis to quality test. So optical inspection and electrical inspection can be combined into a single station. And that basically gives you just one end of line station. You connect all your boards in the test jig, and we will do the inspection in parallel. So effectively, the entire system of testing can be handled by TRiMiTi. Now, going to the next part, which is the rework areas. And when we talk about rework areas, we need to focus on what comes out of quality checks and what comes out of testing. And in the previous videos, I already showed you a pallet. We have 4 PCBs on there, and there we had 1 or 2 PCBs which were defective. So how do we do this? So we have a simple hardware setup. We have a computer, 2 cameras, a small AOI cube, which you can see here on this side. And this is the loading area. So you place the PCBs in the correct orientation in the first step. In the second step, do the AOI testing. And in the third step, as you can see here, we will do the rework sorting. So when you look at a particular pallet, take the part. So our system knows which part was taken, and our system knows whether it was placed correctly in the OK or NOK section. So just to elaborate a little bit more, how we do that is here you can see we have tracking algorithms. And as you can see, our system is tracking the board and not the person's hand. And we have here these funny or nice looking color codes. So what we have done in Nexustec is we have developed our own passive optical marker. And I think you can see it here in my hand. So it can be used for tracking tool, but it can also be used for different objects in production environment. So we can know their position from the camera's point of view. We also know their orientations. So effectively, if this board was placed 180 degrees other way around, our system is smart enough to basically change the tray numbers automatically. So we don't have to rely on worker not making any mistakes, but effectively we will cover any mistakes that the worker is doing. And as you can see here, my colleague, he actually sorted the 2 NOK boards in the NOK part, 2 OK boards in the OK part. And based on that, we can analyze and we can tell you whether your OK NOK sorting was done correctly or was there any mistake in there. Now, coming to the last bit in the EMS. Now, let's say you have done your manufacturing and now you need to put everything in a box so it can be shipped to your customer. So this customer could be your end customer, so it has to go in a nice cardboard packaging, or it could be you're supplying to next in line, which means it has to go in some kind of trays put in a pallet or something. So we will just show the first example where you're packaging whatever you manufactured in a box. And as you can see here, it's a simple instruction that we give to the worker, and it gives you a nice workflow on the right side. It tells you what you need to do. And as you can see here, my colleague, he likes to play around with the system. So he's basically trying to place these PCBs in different locations to ensure, oh, the system is not going to make it, I detected a PCB in the right location by mistake. So as you can see here, unless and until all the parts are placed in the right location, our system will not say that it's done. And you can already have all of your packaging processes ensured in this way, not necessarily the EMS processes. It can be for even mechanical parts. It can be for anything else. And as you can see here, we are not just checking inside the box, we ensure that the box is closed properly. And in the last, you're also placing the tag in the correct location for the box. And once all of these are done, we will say, okay, the packaging process was complete. And now this box can be sent over to the customer or whoever is further down the line. Now, to explain what we saw at different levels for the EMS, we are not looking at just one area or one particular failure. We are looking at the whole manufacturing in one frame. So what we are doing, we are looking at assembled product, right? But further down in assembled product, we are looking in working area. Then we are looking at even down in working area, down to the assembly area. And then further down, all the single checks for the assembly, which are assembly checks via camera, they are taken care of. And now that's the input part, but the output part, all of these, they have corresponding side or corresponding box on the right side. So effectively, every assembly check, we will make sure that components are okay, that positions are okay. For example, in assembly area, we will do the process and components okay and okay collection together. For the working area, we will verify the completeness of the process. And then effectively for the whole product as a whole, we will hand over all the data that we save over to MES or ERP, or if you use any kind of EDI systems that need to have these kinds of data sent down to your customers, then we can also do it over that particular framework. So basically, to conclude, what we have is real-time data collection. We have integration with MES ERP systems, and we have more or less real-time operator feedback. And the benefits that you have from this is that you have absolute zero defects in your EMS. You will eliminate all of your human errors. And let's be honest, you cannot have a perfect process with only human oversight, but with a machine intervention, we can ensure that any kind of human errors are eliminated. Then we have cost saving through improvements in efficiency. The other benefit we have is because we have solution that addresses every single part of your manufacturing, we can provide you easy scalability. And lastly, but most important, we have an improved customer satisfaction. Now, after having presented all of this, I'm pretty sure the next obvious question you're all asking, oh, it's going to cost me a lot. But that's not the case because effectively we have developed a software solution that can be scaled up. That means on our side also we have done it in such a way that the applications can be programmed in a fairly quick manner. We could do an application for you in less than 2 to 3 days once we have all the details, which means the price from our side we can offer at a very good starting price point, which is about 2,25,000 rupees or 2,500 euros. And from that point onward, depending on how complex your system gets, the price could go up. But that's basically TRiMiTi at a glance with focus, particularly. And I would like to thank you all.